Okay, now on these problems, some of them can factor, some of them are non-factorable. Okay, we just solved. This is the only one out of the four we do today that you can do both, and I'm going to do it both ways. But all the other ones are not factorable, and we'll talk about that. Okay. So the first thing, forget about the zero right now. Okay, these do share something in common. What can I pull out of both these terms?
An x, cosine x.
A cosine of x, right? So I'm going to go ahead and on the outside here, pull out a cosine of x. And in parentheses, I have equals 0. Okay, what would I have if I pulled a cosine out of cosine cubed?
Cosine squared x.
Cosine squared of x. Okay, and most people don't forget this part. They don't miss that, but what would I be left if I pulled a cosine out of that? 1. A negative 1. So don't forget that. You have to have something in that position. And again, pulling something out is technically called factoring as well. It's not our typical having two binomials. Okay, but if you did a quick mental check of distributing, okay, if I did cosine times cosine squared, would I get cosine cubed? And cosine times negative 1, would it work? Yes. Okay, at this point, I'm going to make two separate equations. Okay, I'm going to split it here with a red line. Okay, on the left, I want to know when would this stuff on the outside equal 0, and when would all the stuff in the parentheses equal 0. So cosine of x equals 0. Okay, when does cosine squared of x minus 1 equals 0? Okay, now, because if this turned into a 0 right here, it'd be 0 times, who cares what's in the parentheses, I'd get a final answer of 0, right? Or vice versa, if all of this stuff here turned to 0, it'd be 0 times, who cares what's on the outside, it would all turn to 0, right? Okay, the one on the left, the cosine of x minus 0, see how, or equals 0. See how I left it blue? Because there's nothing to do with it. I can't do any more work there. This one I can do a little solving. I can't use the unit circle yet because I've got this. Okay? I'm going to solve this. Okay, my goal is to turn this into a single cosine of x. How do I get that negative 1 out of there? Plus 1 to both sides. Y'all agree? So now I have cosine squared of x equals 1. Yes, the opposite of squaring something is a square root. So in order for that to go away, I need to square root. Now, one thing I don't like about solving is people always miss this. Anytime I do a square root, you have to have a positive and negative number. A little side note, for example, what if I gave you a simple equation like this? There are two numbers that would produce 16. Positive 4 and negative 4. Does that make sense? So when you are doing square roots, don't forget you have to have plus or minus. If you don't have plus or minus, you're going to miss out on some of your answers. Okay, what is the square root? 1. So now, when does cosine of x equal positive 1? And when does cosine of x equal negative 1? Okay, now it's all unit circle time. Is cosine the first coordinate, second coordinate, or outside? First. So I want to look around the unit circle, and I want to find all the angles where I see a 0 in the first coordinate, a positive 1 in the first coordinate, and a negative 1 in the first coordinate.
So 180 degrees.
Okay, so I notice right here, here's a 0, and there's a 0, right? And here's a positive 1, and here's a negative 1. Does that make sense? So there's 4 different angle measures, and we're going to answer in radians. And our answers we're going to put in braces here. Now, technically, I don't care what order they're in because they're all accurate, but I always start from 0 and work my way around. So 0 works for radians or degrees. Okay? And then the next one is 90 degrees, but I prefer radians. So pi over 2. The next one is 180, and radians is pi. And then the last one is 3 pi over 2. This is it. That's my answer. Now, will you always get 4? No. It could be less than 4. It could be 2. It could be 1. Okay? In this original, if I plugged any one of these angles in, it would produce a 0. Okay? Now, there's technically more than this. There's an infinite number of answers. So, for example, right here, that's technically 90 degrees, or pi over 2. That would create 0. Okay? But there's nothing saying, for example, that I just have to stop there. I could also go all the way around again. Does that make sense? And that would also produce a 0. Or I could go around again, and that would produce a 0. And I could just keep going, right, until I get to that same spot. But if I look up at the top, and we'll talk about that notation later, okay, in my instructions, it's limiting me between 0 and rushing right up to 2 pi. And what's 2 pi in degrees? 360. Does that make sense? Okay, so when you get here, a lot of times people say, do I put 0 or 2 pi? Like, do I put 0 and 360? Do I need them both? Okay, so it wants you to include 0, but not include 360. Just get right up to it, like the 359.999, right? Okay, let me show you the way I could have factored this, because I don't like this plus and minus business. People miss this all the time. I'm just going to get rid of some of this. This actually factors, doesn't it?
Yeah, it's plus 1.
This is the difference of 2 squares, right? So this is cosine of x plus 1 and cosine of x minus 1. Now, the only reason I like the factoring better is you never miss the middle stuff. Does that make sense? Here you would say, when does cosine of x plus 1 equal 0? And when does cosine of x minus 1 equal 0? And I guess these would just be flipped, but you get the same thing, right? So factor if at all possible. All right. Problem 2. All right, I'll give you a second to write it down. Okay, first thing I notice is I have trig ratio names on both sides of the equal. Let's move that sine of x to the other side. So now I have 2 cosine of x times sine of x minus sine of x equals 0. Okay, like the last problem, these share a common item. And this is a term, because it's all being multiplied together, and this is a term. What can I pull out of both those terms? Sine of x. So sine of x, and then in parentheses, I would get 2 cosine of x, and don't forget the minus 1. Okay, at this point, I'm going to separate it and make 2 equations. All right, my 2 equations are going to go right here. On the left, on the outside, when does sine of x equal 0? There's nothing more algebraically I can do for that one. That one's ready for the unit circle. Okay, on the right, when does 2 cosine of x minus 1 equal 0? Is this factorable?
Maybe.
Number 1, do you even see a square in there? No. Okay. So there's no square in here, and that 2 kind of messes thing up. There's no middle, there's no middle term. It's just a binomial. Does that make sense? So the rest of these problems, no factoring. We'll save that for next class. Okay. Just solve. Solve it like a regular 2-step equation. What would step 1 be? Plus 1. What would step 2 be? So now I get cosine of x equals positive 1/2. Do I care about the plus minus business? No, because there's no square roots. Okay, so this is a much easier problem. Now you'll notice I'm looking at two different trig ratios. Okay, I want to find all, let's start with sine. I want to find all the places where sine of x equals 0 is sine the first coordinate, second coordinate, outside. Second. I see one right here, and I see one right here. Okay, next one, I want to find all the coordinates where cosine of x equals positive 1/2. Let's highlight that in blue. Positive 1/2. Do you see it? I see one right there. Any other ones? Good, down there. Okay, all of the things I highlighted are answers. And let's answer with braces. Brace here. Again, I don't really care the order for the most part, but to be a little bit more proper, we'll start at 0 and work our way around. One lap around the unit circle. Okay, so 0 and then 60 degrees, but let's answer in radians, pi over 3. The next one is pi. And then the last one is 5 pi over 3. And these are the angles I'm looking for. Okay, that would produce those ratios for sine and cosine. And if I plugged them up into the original, would balance out. Okay? All right, here we go. Number 2A, aka 3. Okay, this one. This is a little different than the last problem. So the last problem, I moved everything to one side, right? And I could technically do that. Don't copy this down, but let's just talk about it. I could do this, right? But does that factor? No. No. What messes it up? It looks like the difference of 2 squared. Like this looks like the difference of 2 squared, but what's messing it up?
3.
That 3. There's no way I would have something that looks identical, right? So if I had a problem that started like this, I would just go back to where I originally began, right? So my goal is to get this tangent all by itself. So let's not move it that way. Okay, this is a one-step algebra to get tangent squared by itself. What would I have to do? Good. So I would get tangent squared of x equals 1/3, right? And then what's the opposite of squaring something? Square rooting. Okay, so now I get tangent of x equals, and don't forget this positive negative business. Okay, this is a little weird because I don't technically have this on the unit circle. I could simplify this a little bit, right? This is the same as positive negative square root of 1 over square root of 3. What is the square root of 1? 1. So if I did a little math down here, now I've got positive and negative 1 over square root of 3. And technically, I kind of have that on my unit circle. But the correct answer, like if you looked on the textbook or online or anything, you wouldn't see any of these. I just put those up there to show where we got those in the fractions when we made the unit circle. Okay, because you would have to rationalize denominators. Remember rationalizing denominators. No radicals in the denominator, right? Multiply by a fancy 1. Y'all agree that's a fancy 1? Okay, so now we get positive and negative square root of 3 over 3, because this would make square root of 9. What is square root of 9? 3. Okay, tangent. So tangent, first coordinate, second coordinate, outside. Outside. And we're looking for all the positions where I see a positive or negative square root of 3 over 3. I see one right here. I see one right here. I see one right here. And I see one right here. 4 answers again. Okay, so the first one is pi over 6. Second one is 5 pi over 6. Next one is 7 pi over 6. And the last one is 11 pi over 6. Whole lot of over 6s, right? Okay, last problem. All right, right out of the chutes, it looks like it might factor. Like this looks like the difference in 2 squared, but what messes it up? At 2, okay? So this is not one that's factorable. So I'm going to solve it like an equation, okay? It is one I can take a square root of. Remember, the only time I can't take the square root is if I had something like this, where I had a squared and a normal one, okay? Those are not square rootable. You can't get rid of the square root if you have a single power item, but this one's okay. So let's do the regular 2-step algebra. What's step 1? Plus 1, and what would be step 2? Good, so I get cosine squared of x equals positive 1/2. How do I get rid of squaring something? Square root. So now I get cosine of x. Once the square is gone, now I can look at the unit circle. Don't forget that you have a positive and negative square root of 1/2. Now again, this is not the unit circle, because it's like I can give them each their own square root, right? And what is the square root of 1? 1. So right now I have 1 over the square root of 2. Also not on the unit circle. So don't be afraid to rationalize the denominator, right? Let's multiply it by a fancy 1. And I get positive and negative square root of 2 over 2. Okay, cosine. Is that the first position, second position, or outside? First. So I'm looking for a positive and negative square root of 2 in the first coordinate. Okay, I see 1 right there. I see 1 right there. I see 1 right here. And I see 1 right here. 4 answers again. Okay, so working my way around. Pi over 4. 3 pi over 4 is the next one. 5 pi over 4. Oh, look at this. A lot of over 4s this time. And last but not least, 7 pi over 4. I brace in. Final answer. And we are finished.